Hello and welcome to the MathOS channel. In this video, I'll talk about a complete elementary result. I'm sure that you've already been asked to bound from above the sum of a list of real numbers while trying to solve some exercise. Here's one way to do it. The sum s is less than or equal to its largest term times the number of terms. But what is precisely the number of terms? Well, that's easy. It's q minus p. Oh, sorry, I mean q minus p minus 1. Or maybe q minus p plus 1? Okay, you got it. In this video, I'll provide you an easy way to never hesitate again in that kind of situation. Consider little cars aligned along the road, numbered from p to q, where p and q are positive integers, such that p is less than or equal to q. How many cars do we have on the whole? To find out the number of cars, we can add other cars, numbered from 1 to p minus 1. Clearly, the total number of cars has climbed up to q. As a consequence, the number we are looking for is the difference between the new number of cars and the number of cars we've just added. And this difference can be written as q minus, in parentheses, p minus 1, or q minus p plus 1. And voila! I suggest to call this the little cars theorem, or in French, le théorème des petites voitures. Now, back to the initial question. Applying that formula, we see that the sum s is bounded from above by, in parentheses, q minus p plus 1 times the maximum of u sub k with k running from p to q. And similarly, it's bounded from below by q minus p plus 1 times the minimum of u sub k with k running from p to q. And now, here is an exercise which illustrates the idea. Given two positive integers p and q, p being less than q, we shall prove that there exists a positive number a such that the sum for k from pn plus 1 to qn of 1 over k is no less than a. In that sum, the number of terms is qn minus, in parentheses, pn plus 1, that is q minus p times n, and the lowest term is 1 over qn, the last one. Therefore, the sum is bounded from below by q minus p times n over qn, which is equal to 1 minus p over q. As a special case, taking p equals to 1 and q equals to 2, we obtain the following inequality, which is quite a classical one. Now, let's move to another context. Given three positive integers p, q, r such that q is less than r, how many multiples of p are comprised between q and r? Such an integer must be of the form k times p, where the integer k is such that the following condition holds. That condition is equivalent to this one, and therefore the number of convenient values of k is given by floor of r over p minus ceil of q over p plus 1. For example, the number of multiples of 7 comprised between 1400 and 2048 is 92. Now let's look at the last example borrowed from the theory of infinite series. Let's U denote a sequence of positive real numbers. We assume that there exists some alpha between 0 and 1 and a positive integer p such that u sub k plus 1 over u sub k is less than or equal to alpha for all integers k starting from p. If we multiply those inequalities all together, for k from p to n minus 1 for some integer n greater than p, we obtain the following inequality, which, after some cleaning, becomes u sub n over u sub p less than or equal to alpha to the n minus p, or in other words, u sub n less than or equal to k times alpha to the nth power, where k is some positive constant. We know that a geometric series with common ratio less than 1 converges. So this comparison allows us to conclude to the convergence of the series of u sub n. Okay, that's it for today. I hope that you'll find this video useful and that we'll meet again very soon on this channel.